Now we want to discuss how cache misses are handled by directed map. What happens exactly when you have a cache miss?
Okay, so now let's quickly revisit this example that we had seen before, where we talked about your CPU is trying to load some address. You go to the cache. From this address C, you can look at it, compute the byte offset, the index, and the tag. Right? You go to that line that is given to you by the index. You look at the tag, but the tag that you have here does not match the tag that you have in your address C. If you do not have a match, then you have a miss. When a miss happens, what did we say should happen? Well, first of all, okay, so the moment we detect that we have a miss here, we are going to tell the CPU that there was a miss, right? So CPU, we have a miss. Now the controller in the CPU is going to start stalling. It's going to stall and not do anything, just like we did for the pipeline hazards, right? So CPU is going to stay where it was. In the meantime, we have a different controller sort of closer to this cache, which is going to take over. So that controller, when it takes over, what it does first is it's going to go to the memory, to the right address C. You're going to grab this data, bring it back to the cache. All the meanwhile, the CPU is installed. You put that data in the data position. You are going to take this tag, whatever it was. Let's say it was a number, I don't know, 20 or something, for example. And you are going to update the tag that you have in your cache to this value, right? Because you want to remember for the next time that, oh, this is the tag that corresponds. And the moment you get this, you also want to make sure that you set the valid bit to 1 in case it wasn't 1 before. So now everything is okay. The tag is updated, the data is updated, the valid bit is updated. You can go back to the CPU and say you don't need to install anymore. Start doing your work as you would otherwise do. This is how we handle cache misses. There is a small difficulty here that has to be added, which is you remember that the instructions, just like the data, are going to be in the cache. When you have a cache miss on instructions, because we have a pipeline system, by the time you detect that there has been a cache miss, you might have already fetched the wrong instruction from the memory, from the cache, right? And if you have the wrong instruction, the next steps in your pipeline might be incorrect. So what you need to do is when you install, you have to also just subtract 4 from the current value of the PC, and that ensures that everything remains correct. Okay, so we discussed how each miss requires a trip to the CPU, to the memory, and the CPU has to install. That's, of course, detrimental to our performance. Are there ways to improve the performance when you have a miss? When your block size is more than one double word, there are some tricks that you can use. There are basically two tricks, right? So let's say you have a load instruction, and the load instruction is asking for this double word in your block, right? So we have here a block size of 4. Let's say this second element in my block is what the CPU has asked for. When I go to the memory, I'm going to read all 4 of this. There are two small tricks that you can use here. One is that as soon as you read this one, you can stop the stall of the CPU. So you can tell right away to the CPU that the CPU can continue what it is doing as soon as you have this. And then these will be filled out while the CPU is doing its own work, right? So you do work in parallel. That's one solution. It's called early restart. And you can just take this idea one step further, and we know which of these four addresses CPU is asking for, right? So when we go to the memory and ask it for this block, we can also tell the memory that, oh, by the way, please send us the second block first, because we want to early start. But if we have this, we know we can start even earlier, right? I mean, it doesn't matter in what order the CPU is going to send back these data, right? So there are going to be four things that need to be sent out, four blocks four double words in this example. So by default, you would just go, pink, green, yellow, orange. But the cache can tell the memory that, oh, please send me this green one first, because that's what the CPU wants.